We also want to be aware of the domain of this function. Where does this function exist at? To understand that again, we must remember that the value underneath the radical, the radicand, must be 0 or positive, and that will determine where our domain is. So this particular function right here, to find out what its domain, let's look at 3x plus 12, and let's look for all the values that make that greater than or equal to 0. To solve this inequality, subtract 12 from both sides. Divide both sides by 3. Gives me a -4 if I didn't skip a step there. So my domain are all my values of x greater than or equal to -4. And then to represent that solution, there's a couple of ways you can represent that solution. One way you can represent that is graphically. I find my breakpoint, which is -4. And this tells me all values greater than 4, so I'm going to shade that in on the graph. -4 is also a solution, so I'm going to do one of two things. Either I'm on -4, I'm going to put a dot that's filled in, or you might see some people put a hard bracket to represent what its boundary point is. My preference is interval notation. Interval notation talks about what are the endpoints where the solution is found. One endpoint is -4. It's a solution, so I'll put a hard bracket on it. And all the remaining solutions are all the way out to positive infinity. And positive infinity or negative infinity, but here positive infinity has a soft bracket on that because we can't pinpoint precisely or precise location of infinity. So all functions have a domain. What are the values to ensure that the radicand is positive or 0 or 0? We solved this, we set to an inequality, and I found out in this particular function, my domain includes negative numbers, but those negative numbers make the radicand positive or 0. So that's all right.